All right, we are now recording. All right, so we're done with 2 exams now. We're on to our 3rd exam. You should have received an email back from me about your exam. If you didn't, let me know. For those of you that took it, of course. Keep in mind you're allowed to drop 1 exam. In general, I don't have makeup or rescheduled exams. So if you didn't take the test on Friday, it goes in my grade book as a 0, but you get to drop 1 exam, 1 and only 1, and you get to drop 1. So it was 10 questions, 10 points each. I gave the video on the solutions also over the weekend, so you can look at that. And you should have gotten an email back from me about your individual score, right? And remember, overall, any individual score and exam, 90% is an A, 80 is a B, 70 is a C, 60 is a D, less than 60 is failing. Okay, if you're close, that's where minuses and pluses come in. I've got it all broken down in my syllabus. So if you get 89, I think that's an A minus, and an 88% is a B plus, and likewise all the way down. So 80 is a B. So if you're at 79, you're close. So I would give you a B minus, and if you're below that, 78, that might be a C plus, and so on. The one exception is a C minus. We're not allowed to give C minus grades. There's no such thing as a C minus at CSM. So that's not allowed to be given out. Okay, so we've taken 2 out of 5 exams. So the next exam is chapter 3. A heads up that this is our longest chapter, you may notice. So the first one was 5 sections. This one is 8, but this is 11 sections. Okay, so it's our longest chapter. And then chapter 4 has 7 sections, because we're not doing 4, 6. And our last chapter, chapter 5, which includes 4.9, which in my opinion should actually be part of chapter 5. There's 6 sections. So this is our longest chapter. So calendar-wise, that pretty much takes us the entirety of March. Now that we're into March, chapter 3 is basically a March chapter. So our next exam is scheduled to be Friday the 26th, our last day of March, and that fits perfectly because that's right before the 1-week spring break that we have. So I think it's a nice time to have the exam then. So that's 4 weeks. Okay, so we have 1 week, so Friday quiz, 2nd week, Friday quiz, 3rd week, Friday quiz, and then 4 weeks, and then we have the exam, and then we have the week off for spring break. Okay, so it looks like that's what's happening. Right, so the topic is the derivative. We're going to be doing derivatives, and more derivatives. And you are very rarely from here on out going to have to use limit h approaches 0, f of x plus h minus f of x all over h. Now, I will need that in the derivation of the formulas, okay, but you don't need that. You can just use the formula. So be ready to have your next cheat sheet, your next formula sheet. Again, you only need 1 sheet. We've got 11 sections for the next exam. So budget your paper, so to speak, accordingly, okay? All right, so we're on to 3.1. Okay, so here we go. So derivative rules, shortcuts, okay? So you did a lot of limit h approaches 0, f of x plus h minus f of x all over h. I will do a lot of them still. You don't have to, for the most part. Okay, so we're trying to come up with derivative rules, shortcuts now, so we don't have to keep doing that. Okay, how about f of x is a constant? All you have is a constant. F of x equals 7, f of x equals -3. Okay, well, we know that looks like a horizontal line. What's the slope of any horizontal line? 0, right? So f prime of x is 0. So first shortcut, if all you have is a constant, the derivative of a constant function is 0. Okay. Now, if we did the limit definition, you'll get that also, but I think graphically it shows it to you. F of x equals k, y equals k, like y equals 7, y equals 1,000,000, y equals -pi. Those are horizontal lines. Derivative means slope. What's the slope? 0. Okay. So just about the simplest derivative there is if you have a constant, a constant function, its derivative is 0. So if I just give you a number as the function, the derivative is 0. So I say, what's the derivative of 5? 0. What's the derivative of negative 21? 0. What's the derivative of pi over 2? 0. All you have is a constant function. Okay. All right, the next shortcut I've actually alluded to in the last chapter. Okay, suppose you have a linear function mx, y equals mx. Okay? And if you stop and think about it, well, derivative means slope. So what's the slope here? M. So if we have a first degree function, which is a line, the derivative is m. But here's the actual limit definition. Okay, you're not really responsible for this. I'm responsible for it. So I'm just showing to you by the limit definition. So f prime of x, limit h approaches 0 of f of x plus h minus f of x all over h. Okay, and since you're not responsible for a lot of this stuff, I'm going to zoom through a lot of it. So if you don't understand everything is in my head spinning, I have no idea what he did. That's okay. You're not responsible for it, but at least you know, okay, the teacher showed me why this formula works or blah, blah, blah. Okay. So that's really pretty much the gist of it. Okay. So clean that up. Limit h approaches 0, mx plus mh minus mx over h. Mx cancels out. H cancels the h. So I have limit h approaches 0 of m, and that's equal to m. So the derivative is m, just as we expected. So if you have a linear function of the form mx, the derivative is m. Okay, so that means what's the derivative of 23x? 23. What's the derivative of pi x? Pi. What's the derivative of negative 3.17x? Negative 3.17. Okay. All right, next big rule is the power rule. I'm actually not going to prove it right now. If I have time, I'll prove it in another day in the future. It's just sort of a plausibility argument right now. So first I made a little table here. F of x, f prime of x. So what's the derivative of x? Well, based on what we just said over here, it's the coefficient, which is 1. So derivative of x is 1, but I added some extra stuff for emphasis. X is like x to the 1, right? And for some strange reason, I snuck into x to the 0, but there's reason for that. After all, what is x to the 0? 1. So it's still a true statement for whatever reason I put it. So the derivative of x to the 1 is 1x to the 0. Okay. Now, in the last chapter, we did this quite a bit, the derivative of x squared. You do the limit definition, limit h approaches 0, f of x plus h minus f of x all over h. The derivative of x squared comes out to be 2x, which I can sneak in as 2x to the 1, right? We did this, x cubed. The derivative came out to be 3x squared. We did this, x to the 4th. That was question 10 on the exam, right? If you did the right way, it came out to be 4x to the 3rd power, 4x cubed. So the rule is here. You've already seen it maybe, but I'm trying to cover it up. See if we can develop a pattern. Derivative x to the 1, 1x to the 0. X squared, 2x to the 1. X cubed, 3x squared. X to the 4th, 4x cubed. So what seems to be the rule in general, if I have x to the n, it looks like that exponent comes down in front, right? And then we subtract 1 from the exponent. And that does happen to be the root. Now, by the way, this does not qualify as a proof. It's a plausibility argument. You don't even have to write that down if you don't want to. But so far, the pattern seems to work. Okay. We are going to make the bold claim it works all the time, although I certainly have not proven that. This does not qualify as a mathematical proof. It works for 1, 2, 3, 4. You say, how do I know it doesn't work when I plug in 524 or fractions or decimals or negative numbers? Okay, so we're making a pretty bold claim right now without proof, but if we have time, we'll prove it in a future section. Okay, but we will go ahead and state it right now without proof. Okay, n x to the n minus 1. Okay, so this is a very powerful rule, the power rule. Okay, so here's another way you can write derivative. Just write the function and then put prime. X to the n prime, meaning the derivative of x to the n is n x to the n minus 1. Okay, so exponent comes down in front. then you multiply by x to the 1 less than the original exponent. Now, you can do these. We did a lot of this in chapter 2. Okay, but we are going to make the bold claim without proof that it works for any real number n. Okay, that means for fractions, decimals, big, small, negative, irrational, it works. Okay. All right, and a little bit of a reminder of how we're going to write derivative. Y prime f prime of x and dy dx. The way we're going to say it is dy dx. It looks like dy over dx. In fact, it sort of looks a little bit like delta y over delta x, and even the word delta starts with a d, and that's for good reason. So you can think of dy dx as delta y over delta x as delta x approaches 0. Okay, when the delta x gets really, really, really small, and then in general, the delta y would also get small. So we're going to call this dy dx, one symbol. So don't like cancel out the d's or something like that. This is one symbol for derivative. Okay, you'll see me put all of these there just so you can kind of get used to all of them. And we showed you in the text, there are other abbreviations for derivative, but these are the ones that are used most of the time. So get comfortable with all of these. All right, so some examples. Okay, d dx of x to the 6th. The language we will say sometimes is the derivative of x to the 6th with respect to x. You'll hear me use that language. I'm not, holding you responsible for saying the language, but just that's why I'm not writing it down. We say the derivative of x to the 6th with respect to x. So what's this with respect to x stuff? It tells you that x is the variable. So wasn't x always the variable? No. Later on, the variable is going to be t quite often for time, or the variable might be q or w or whatever. Okay, the derivative of x to the 6th with respect to x, or d x to the 6th dx. Okay, so 6x to the 5th. 6 comes down, subtract 1 from the exponent, 6x to the 5th. Okay, another way to write it is x to the 100th prime. And give me the derivative of x to the 100th. 100 comes out in front, x to the 99. Okay, so this is the power root. It's a pretty easy root. Okay, most students don't have any trouble with that one. Okay, how about x to the 2.3? What's the derivative of x to the 2.3? Y prime is 2.3 x to the 1.3. Okay. All right, then a little bit harder when you have to figure your roots of exponents. What is the derivative of square root of x? And you had something like that on the test also. Okay, so I'm piggybacking off of that, where I would not let you use the shortcut. But what was the derivative of square root of x, right? So the way to do this now, rather than doing the limit definition and multiplying by the conjugate, which is still correct. And by the way, like I said, you probably aren't going to do much of this for the remainder of the semester, but maybe occasionally, but you still need to do that for the final exam. Final exam, I might ask you to, to prove the derivative using the definition of the derivative. Then you have to do limit h approaches 0, f of x plus h minus f of x all over h, all that stuff. Okay, so the trick this time is to treat this as x to the 1/2 power. Okay, now I can do the power rule. Right, so exponent comes down 1/2, x to the 1/2 minus 1, which is negative 1/2. Clean up the algebra, 1 over 2 radical x. And if you did that problem on the exam correctly, the derivative of this is this. And again, a side note, okay, some of you went from here to here by doing this. Okay, I said I wasn't going to accept it. Some of you put it, and guess what? I didn't accept it. Okay, for the next exam, I will accept it. Okay, so you may go from here to here from now on in this class, unless I say do it by the limit definition. Okay, so now you can go from here to here, but not the last exam, as I mentioned. Okay. All right. How do you differentiate 1 over x? Okay, I think I mentioned this before. Differentiate, if you hear me say in this class, differentiate, it means take a derivative. Okay, so yes, we know there's an English word differentiate between one thing and another, right? But in a calculus class, when you hear the word differentiate, Okay, it usually means to take a derivative. Okay, so technically we don't say we derive a function because that has another meaning. Okay, so we say differentiate a function. It's the process of taking a derivative. So the verb form is differentiate. Okay, so how do I differentiate 1 over x? Well, in order for me to use the power rule, write it as x to the -1. And there we go. So what's the root of x to the -1? -1, which means just put negative, x to the -2. And then use our normal rules of not leaving our answer with a negative exponent, -1 over x squared. Okay, and again, in chapter 2, we actually did some derivatives like this, where the answer came out to be the derivative of 1 over x is -1 over x squared. Okay. Okay, the next rule to show you is the constant multiple rule. Okay. By the way, the book gives a nice summary of all these things. So you say, how do I put all this on my cheat sheet? I'll tell you when's a good time to start putting some of this on your next cheat sheet, because this chapter, there's a lot of derivative shortcuts. In fact, you should be happy that the derivative shortcuts, that you don't have to keep doing limit h approaches 0 f of x plus h minus f of x all over h. Okay, and you might say, are there a lot of rules? Yes, there are. Right? It's our largest chapter. Okay, so even though, yes, we are doing derivative shortcuts, for which you're probably thankful for, it doesn't mean this chapter is easy. Okay, there's lots of rules, lots of stuff is going on here. Okay. Okay, what's the derivative of a constant times a function? Okay, I'll fly through the derivation, which you're not responsible for. So I'll go pretty quickly using the limit definition. So y prime is limit h approaches 0, k f of x plus h. You replace this thing here with x plus h minus the original k f of x divided by h. Okay, I can factor out the k, limit h approaches 0, k f of x plus h minus f of x all over h. One of the limit laws says if you have a limit of a constant times a function, it's a constant times the limit of the function, i.e. you can factor the k out. K limit h approaches 0, f of x plus h minus f of x all over h. That is the very definition of f prime. So k f prime of x. Okay, so in short, how do I take the derivative of k f of x, where k is a constant? It's k times f prime of x. Ignore that. That looks like just a stray mark there. Okay. So if I have a number times a function, the derivative is the number times the derivative of the function. Okay. And here are some simple examples. You have the coefficient. Y equals 7x cubed. Okay, now what's the derivative of x cubed by the power rule? 3x squared, right? So what if I have a 7 in front? Y prime is 7 times the derivative of x cubed. 7 times 3x squared, or 21x squared. Meaning, if you're trying to use the power rule combined with the constant multiplier rule, now the next shortcut is, if you have a coefficient, simply go 3 times 7 is 21 and subtract 1 from the exponent, 21x squared. Okay, it's pretty straightforward. So, example, suppose f of x is 4x to the 5th. What's the derivative? Just go 5 times 4 is 20, x to the 4th. Okay. Okay, what is d dx of 1/2 x squared? Okay, so don't get scared by this notation. It still means derivative. So how do I say it? D dx of 1/2 x squared, or the derivative of 1/2 x squared with respect to x. Now, how do I get just x? Well, do the same game as over here. 2 times 1/2, 1. Coefficient is 1, which means you don't have to write it. X to the first power, and if the exponent is a 1, you don't have to write that either. So the answer is just x. Okay. Okay, next rule. Derivative of a sum or a difference, f of x plus g of x prime, or f of x minus g of x prime. So what if you have something times something? Sorry, something plus something or something minus something. How do you differentiate? Okay. This rule says just add the derivatives. F prime of x plus g prime of x or f prime of x minus g prime of x, as the case may be. Okay. That's what you probably would have guessed in the first place. Okay. So let's look at x squared plus 5x. What's the derivative of x squared? 2x. In fact, it's still on my chart here. What's the derivative of 5x? 5. So how do I take the derivative of the sum? How about take the derivative of this one plus the derivative of this one? That's exactly what you do. It's very intuitive. Okay, so y prime is 2x plus 5. Okay, so the derivative of x squared is 2x plus the derivative of 5x is 5. So if you have a sum or difference, okay, just take the derivative first, plus or minus, as the case may be, derivative of the second, and all the way down the line. Okay, which means we can now differentiate any polynomial. If we have any polynomial, we can find its derivative. Okay, so let's take a look at x squared minus 5x plus 6. What's the derivative of x squared minus 5x plus 6? I take the derivative of this minus the derivative of this plus the derivative of this. Okay, so what's the derivative of x squared? 2x. We got that over here even, right? Negative 5x, that is a linear function, right? Looks like mx. So derivative of negative 5x is negative 5 plus the derivative of 6. What's the derivative of any constant? 0. So it's plus 0. But of course, if it's plus 0, you don't have to write it. So the derivative is 2x minus 5. Okay. So this is the sum rule. Okay. So sometimes called the sum rule or the difference rule. It works the same way. Okay. I'm again supposed to show this to you. So if you want to tune out for a minute or two, you may. I'm supposed to show it to you. You can listen or not, but I'm supposed to at least show it to you, the actual proof. So what is the derivative of f of x plus g of x? Okay. So limit h approaches 0, f of x plus h plus g of x plus h. Okay. Replace all x's by x plus h minus the original f of x plus g of x all over h. Okay, rearrange the terms. Limit h approaches 0 of f of x plus h minus f of x plus g of x plus h minus g of x all over h. The limit of a sum is the sum of the limits. I can break this into 2 right there. Break it up right there. Okay, chop it right like so into limit h approaches 0, f of x plus h minus f of x all over h, plus this part, limit h approaches 0, g of x plus h minus g of x all over h. Okay, and by definition, this is f prime of x, and this is g prime of x. Okay, and working almost the exact same way is if you have f of x minus g of x. Okay, you can run through that, but similarly, derivative of f of x minus g of x is f prime of x minus g prime of x. Okay, so you have to tune back in. Sorry, that was enough of a 2-minute break. But maybe some of you were interested, what's the proof that it works? This is the proof that it works. Okay, so we have a lot of stuff right now. And just in case you want to see it in the text, I'll go over a lot of this stuff. Okay, so on page 172, figure 1, y equals c. Notice it's a horizontal line, slope is 0. Derivative of a constant function is 0. The derivative of c, where c is a constant, with respect to x, is 0. And by the way, up here, they give you the limit definition. The definition, that works also. Okay, then we have the power rule on page 173. Derivative of x to the n with respect to x, n x to the n minus 1. Talked about. They go over a mini proof, which is not really a proof at all. They're proving it just for positive integers. Okay, so what about negative integers and fractions and decimals? So that will all get swallowed up, hopefully, in either section 4 or 5. We'll come back to that. constant multiplier rule, page 175. Okay, I think I used K, they're using C, same thing. The derivative with respect to X of C f of X is C times the derivative with respect to X of f of X. You can factor out the C. Okay, and there's the proof. I went over the proof if you wanted to. And the sum and difference rule, page 176. Okay, I know it looks like we're covering a lot of ground, but most of these aren't really that hard, I think you'd agree. Okay, how to differentiate f of X plus g of X? Just differentiate each. It's the derivative of f of X plus the derivative of g of X with respect to X. Okay, their proof is exactly like mine. And there's a difference rule. What's the derivative of f of X minus g of X? It's the derivative of the first minus the derivative of the second. So d dx of f of X minus d dx of g of X. Okay, and again, please notice there's all these different notations now for derivatives. So you want to kind of get comfortable with all d dx, right? dy dx, f prime of X, y prime, and so on. Okay. Okay, one more big one I want to show you is the derivative of e to the x. And this is really where we get to the heart of matter. You know, why do we have such a weird function of e to the x? I mean, there's got to be some reason, right? So you have 10 to the x and log on your calculator. Okay, that makes sense, base 10. We do everything in base 10. Why is this weird e there? Okay, again, e is an irrational number. If you want to see its value, some of you have a button that does e. If not, you can go e to the first power, which my calculator have to do, e to the first power, 2.71828, blah, 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 right? Okay, how do I take the derivative of e to the x, which I'm going to show you now? What is the derivative with respect to x of e to the x? So I'll go over a derivation of it, okay, but suffice to say, this is the best base that you have, okay? It's the base for natural logs, and maybe that's why it's called natural log. It's a naturally occurring, logarithm, so to speak, okay? Once we get deeper into this chapter and the rest of calculus, you want base e. You don't want any other base. You don't want base 10. You don't want base 2. You don't want base 7. They're actually going to be more complicated than base e. You'd rather be in base e for some strange reason. Okay, so I will go over the derivation of this. So e to the x prime, and yeah, since it's a derivation, if you want to do a mini tune out, again, you may for maybe 2 minutes. But for some of you, you might be interested. Okay, limit h approaches 0, e to the x plus h minus e to the x over h, right? Okay, I can break up e to the x plus h as e to the x, e to the h. Okay, this is a valid step. Although in algebra 1, you probably went from here to here, right? You look at this and say, oh yeah, I can add the exponents. Well, you can go backwards, e to the x, e to the h minus e to the x all over h. Factor out the e to the x. Okay, so e to the x, e to the h minus 1 over h. Okay, now, as far as h is concerned, e to the x is a constant. It doesn't look like a constant, but since e to the x does not depend on h, I'm allowed to factor it out of the expression. Frankly, even if you didn't, you'd get the same answer, but it makes it easier. So take the e to the x out, limit h approaches 0, e to the h minus 1 all over h. Okay, so I got it to the point where the derivative of e to the x is e to the x times this thing. So if I can establish what this limit is, then I can get the derivative of e to the x. Okay. Now you might look at this and say, okay, can I do some algebra trick? The answer is no, there's no algebra trick for this. So all we can do is make a table of values. Okay, so h approaches 0. Cover this up. From the left, negative 0.1, negative 0.01, negative 0.001. Approaching from the right, 0.1, 0.01, 0.001. Okay. Now, to save time, I already did it before. You can try it on your own. Here is what comes out to be. Okay, so I plugged in negative 0.1, negative 0.01, negative 0.001, 0.1, 0.01, 0.0, and so on, okay? So coming from the left, 0.9516, 0.9950, 0.9995. Coming from the right, 1.0517, 1.005, 1.0005. Okay. What seems to be true about the limit? We're approaching 1. Right? So numerically, the limit as h approaches 0 of e to the h minus 1 divided by h is equal to 1. Okay, so I've established that this limit right over here is 1. So going back over here, the derivative of e to the x with respect to x was e to the x. Okay, I already factored out the e to the x. And then I had to take a time out and figure out what this limit was. Okay, and we now see that the limit is 1. So the limit is e to the x times 1, which is e to the x. Okay, so time in, you have to tune in again, I suppose. Pay attention. All right, so in a nutshell, what you now need to know is the derivative of e to the x is itself e to the x. That's a very easy derivative. Derivative e to the x is e to the x. Okay, you're not responsible for this derivation. I'm responsible for this derivation. You're responsible for knowing this. And do you need to put that on your cheat sheet? You could. I mean, it's pretty easy, right? Derivative e to the x is itself. Okay, but a note of caution, watch out, because this is easy to get mixed up. Now that we know the derivative of the exponential function e to the x is itself, do not go like this. So watch out for that trap, right? E to the x prime is not x e to the x minus 1, right? Make it look like the power roots. Oh yeah, bring that down, subtract 1. Okay, not for e to the x, not for exponential functions. Okay, derivative of e to the x is simply itself, just e to the x. Okay. All right, so now we can differentiate any polynomial and anything with an exponential function. Okay, so for practice, y equals 6x cubed minus 12x squared plus 5x minus 4 e to the x plus 7. What's the derivative of the whole thing? Well, it'll be the derivative of this minus the derivative of this plus the derivative of this minus the derivative of this plus the derivative of this, right? Just go on down the line. So derivative of 6x cubed, 6 times 3 is 18, x squared, subtract 1. Next one, derivative of negative 12x squared. 12 times 2 is 24, so negative 24 x to the 1. 2 minus 1 is 1, but of course, if it's a 1, you don't put it. What's the derivative of 5x? 5, linear. Okay, what's the derivative of e to the x? E to the x. What's the derivative of negative 4 e to the x? By the constant multiplier rule, it's negative 4 times the derivative of e to the x, which is itself. So negative 4 e to the x. And you have to be careful because sometimes you look at this and say, wait a minute, I didn't do anything. It turns out, yes, you did take a derivative. It just turns out that the derivative is itself. Okay, so you might look at it and say, oh yeah, I didn't take the derivative. You did, just because you get the same answer. And what's the derivative of 7? 0. Okay, so that's how you end up with something like this. So that's the way that goes. All right, so page 179, derivative of e to the x with respect to x is e to the x. Its derivative is itself. Okay. Quick summary of where we're at. Again, you're welcome to put as many of these as you want on your cheat sheet. Okay. Again, I don't know if I should want to call this a warning, but if we were meeting face to face, I'd make you memorize all these. Okay. Last time I taught on campus, my students had to memorize it, but they said make it easier on us under COVID, so I'll let you have a cheat sheet. So the derivative of a constant is 0. You don't really need this one. It gets summed up in another rule. Power rule, derivative of x to the n, and x to the n minus 1. Okay. You're not responsible for any of these proofs unless I say so. And let's see, constant multiplier rule, page 175. the derivative of c f of x is c times the derivative of f of x, constant multiple rule. Sum and difference rule. Derivative of sum is the sum of the derivatives. Sometimes we use that language. Okay, here's a nice little way to write it in 176. F plus g prime is f prime plus g prime. It's almost like the distributive law. You can distribute the prime onto the f and the g. And likewise for a difference, the derivative of f of x minus g of x is the derivative of f of x minus the derivative of g of x, f prime minus g prime. And the derivative of e to the x is itself, page 179. Okay. All right, what time is it? Doing well. So, good chance to look at some of the problems. So what do we got? 3 to 35, 45 to 61. So we have to go up at least to 61. Okay, so I'll show this for those of you that don't have the book and don't plan on getting it. Okay, differentiate. What's differentiate? Find a derivative, right? That. Okay, then over here. Whoops, aim it right. And some more. Okay, if you see that graphing calculator icon, like next to 43, ignore anything that asks for a graphing calculator icon. And let's see, how high up do we have to go again? Up to problem 61. Okay, so that. All right, and let's see, where's 61? These. Hopefully these are readable enough when you check the video for those of you who don't have the book and don't plan to get it. And there's that. And were we up to 61? Okay, there's 61, right? So that should pretty much do it. Okay. So let's take a look at some of these. The first ones are easy enough that we can just talk about it. Number 3. A little bit of a trick, but hopefully not. Number 3, differentiate f of x equals 2 to the 40th power. Okay. Now you might think of taking the 40 down and then go 2 to the 39th power. Okay. Not so. 2 to the 40th is a constant, is it not? 2 times 2 times 2 times 2, 40 times. It's a super big number. You could punch it in your calculator, but we don't really care. It's a constant. Therefore, its derivative is 0. Right? So the answer to number 3 is 0. That's all. Can you get the answer to 5 pretty easily? 5.2x plus 2.3. So f prime of x, what's the derivative of 5.2x? 5.2. What's the derivative of 2.3? 0. So the answer is just 5.2. Right? Okay, 7 is the last one I'm willing to do just in my head, and we can just talk about it. But after that, I'll show it to you on my paper. Okay, number 7, what's the derivative of f of t is 2t cubed minus 3t squared minus 4t. So again, the letter doesn't have to be x. Looks like they got t, they got r, they got a, they got all kinds of other letters there, but it doesn't really matter. Okay, so number 7, what's the derivative of 2t cubed? You go 2 times 3 is 6, and then t squared, so 6t squared. And do the next one. What's the derivative of negative 3t squared? Negative 3 times 2 is negative 6. T to the first power, so negative 6t. And what's the derivative of negative 4t? -4. Okay, so once again, the answer to 7 is 6t squared minus 6t minus 4. Okay. Okay, number 9, I won't do, but I'll just give you the hint for number 9. Just multiply it out. Multiply it out, then it's easy, right? In fact, I can probably do some of it. It's x squared minus what? 2x cubed, I guess, right? So just differentiate x squared minus 2x cubed. Okay. Then some of the other ones, like 11 and on, you have to get them set up the right way before you start, right? So like number 11, show you number 11, then maybe that's about it. G of t is 2t to the negative 3/4. So you multiply right here, right? 2 times negative 3/4 is negative 3/2. T to the negative 3/4 minus 1. So negative 3/4 minus 1 is negative 3/4 minus 4/4, negative 7/4. Okay, again, ground rules for how I leave my answer. The problem started off with negative exponents. So if they give me negative exponents from the start, you're allowed to leave the answer with a negative exponent. Okay? But if the problem started off without any negative exponents, you shouldn't leave the answer with a negative exponent either. Okay. All right, folks, I don't see anything in the chat. If anybody has a question, you can ask in the chat. Otherwise, I was going to stop, give you some hopefully easy problems to do, and then we're done. Anybody have a question they want to ask in the chat or otherwise? Okay, so right now I want you to type in the chat privately answers to numbers 4 and 6. Okay, so get your cell phone out now, take a picture, or if you've got the book, that's fine. I want you to answer in the chat 4 and 6. What are the derivatives of 4 and 6? And when you're done, you can go. Okay, f of x is e to the 5th power. Okay, and 6g of x is 7/4 x squared minus 3x plus 12. Okay, so if you have the book, just look at your book for number 4 and 6, type in the chat. If you don't have it, take a picture on your cell phone and do a screenshot right now. I'm going to put it down in about 15 seconds or so because the book is heavy. And type your answer in the chat, then I'll see you tomorrow. Okay, so again, just number 4 and number 6. Okay, I will assume that everybody has it now. And I'll stop the share. Okay, if anybody has any question, you can ask Prasanna or me. Otherwise, if you're finished, you can just go ahead and leave. Thank you.